Alright, so today what I wanted to do is finish up half-angle identities, and then tomorrow we are going to just be reviewing. So today is April 7th, and this is section 5.5, half-angle identities. I'll call it day 2. Okay, so I had, let's see, 4 problems for us today. So first couple problems we're going to be solving the following. So solve the following equations on the interval from 0 to 2 pi. Okay, and there's a couple of these. So the first problem looks like this. It says 2 minus the sine squared of x is equal to 2 cosine squared of x over 2. So obviously that's a half-angle identity, so let's do that. Remember that cosine squared is the same thing as cosine of x over 2 to the second, which is the formula for cosine of x over 2 is plus or minus the square root of 1 plus the cosine of x over 2. We're going to be squaring that. When you square a plus or minus square root, they cancel. So this is what we're looking at. 2 minus the sine squared of x is equal to 2 times, it's going to be 1 plus the cosine of x over 2. Okay. You're multiplying by 2 and dividing by 2, so those cancel. And just kind of thinking forward, it'd be nice to have all the same trig functions. So if sine squared plus cosine squared is 1, then we could replace sine squared with just 1 minus the cosine squared. And now we should be able to solve this. So let's do this here. 2 minus 1 plus the cosine squared of x. I'm going to bring the 1 over, and I'm going to bring the cosine over, so I make it equal to 0. Cleaning things up, this would be the cosine squared of x, and then 2 minus 1 cancels, minus the cosine of x is 0. Could factor out a cosine. And at this point, when is cosine of x 0? We know that's from a unit circle right here and right here. So x would be pi over 2, and x would be 3 pi over 2. 90 and 270. We wouldn't be adding the period because that would go outside of the interval. When would cosine of x be minus 1 equals 0, which is asking us when is cosine 1. That would happen right here, when x would be 0 or 2 pi. So these are the 3 answers. We're not going to write 2 pi because in our interval we are not including 2 pi. If we were, it'd be a bracket, not a parentheses. Okay, so 3 more. Second example is similar, except we're going to be dealing with the sine of x over 2 plus the cosine of x minus 1. And that's what f of x is equal to. We'll just put f of x. And what we're going to be doing is the directions are find the zeros, which is similar to what we've been doing. We're just going to set f of x or y equal to 0, and then it's exactly like what we've been doing. Remember, zeros just mean x-intercepts. And then I'm going to plug in my formula here. And at this point, it'd be nice to get rid of that square root. So I'm going to bring the other terms on the other side, and I'm going to square both sides. At this point, we could square both sides. That would get rid of the plus or minus square root. And if we were to FOIL out the right side, if you do this, I'm going to disown you. I'm going to pretend like I don't even know who you are. But if you FOIL that out, 1 minus cosine times 1 minus cosine is 1 minus 2 cosine of x plus cosine squared of x. Let's get rid of fractions by multiplying everything by 2. And let's get everything on one side, make it equal to 0, and then we could factor and solve it. So if we bring this cosine over, that would be negative 3 cosine. And if we subtract 1, that would be 1. So let's tie it all together here. If we get it all on one side, we get 2 cosine squared of x minus 3 cosine of x plus 1 is equal to 0. It's a trinomial. We could factor that. You could use the AC method if you want. At this point, I've showed you the shortcuts a few times, so we have to get negative 3 in the middle. This would be positive 2. This would be positive 1. So let's make it negative 2 and negative 1. That would still, at the end, we'd get negative 1 times negative 1, which is positive. Let's make these equal to 0. So when is cosine of x 1/2? Well, I know it's 1/2 in a 30, 60, 90 triangle. And that would happen at 60 degrees. And 300. This is 60, but this angle right here is 300. In radians, this would be pi over 3, and this would be 5 pi over 3. When is cosine of x minus 1 equal to 0? Well, that happens when cosine of x is 1, which is right here. When x is 0 or 2 pi, we don't include 2 pi for the same reason we didn't include it in the last one. All right, 2 more problems. This is what they look like. So the directions are going to be use a half angle identity to simplify. First problem looks like this. Square root of 1 plus the cosine of 4x over 2. Well, it's a little bit tricky at first, but think about it. 1 plus a cosine is the formula for the cosine of a double angle. Notice that this x and this x are the same. So I'm thinking that if I write this as the cosine of 4x over 2, the formula would be 1 plus the cosine of 4x divided by 2, which is what we wanted. Now, the problem is, this is a positive, right? That's what the problem was. That's a positive problem. The cosine of 4x over 2 would technically be a plus or minus. So the way that we could force it to be positive, because that's what the problem is we could just put absolute value right here, saying that whatever the formula is, if you put absolute value, that would disregard this plus or minus and keep it positive, which is what the problem is. So our final answer for this, and I'll show you another one to help you understand. 4x divided by 2 is just 2x, so the answer would be the absolute value of the cosine of 2x. Let me show you another example. What if it's a negative square root of 1 minus the cosine of x minus 1 over 2? All right, so I see 1 minus a cosine, so I'm thinking that that's the formula for sine of x over 2, which was plus or minus the square root of 1 minus the cosine over 2. And notice this x and this x. So with this formula, instead of being sine of x over 2, if it was x minus 1, then that would be x minus 1. So this would be the sine of x minus 1 over 2. Now the one tricky part is, you see how this is negative? The formula gives us a plus or a minus. So we have to try to think about how we could take that formula and force it to use the negative sign, because that's what the problem was. Well, the way that we could do that is we could force this answer to be positive, and then we could just put a negative sign in front of that. And then no matter how else you do it, this would give you a positive or a negative answer. The absolute value would make it positive, and then the negative would make the whole thing negative. So it's a little bit strange. It's not hard math. It's a little bit weird conceptually. But for homework, this is what I would like you to try to do. And tomorrow we'll just review this stuff. For homework on page 418 to 19, I would like you to please do numbers 51 to 57 odd. All right, so please take a look at those for tomorrow. Thank you so much. Have a nice day.